We are about to lecture on an important aspect of the whole problem. Problems with mixture of operations. We've learned about the operations of plus, minus, times, and division. But in all the problems that we have been solving, we've been dealing with a question that entails only one of the problem at a time. We were dealing with a problem that maybe there was a plus inside. You solve it. Another question altogether, there is a minus inside. You solve it. Another question has a times. You solve it. We are now about to ask ourselves, if we are given a problem and there is plus, times, division, subtraction, in that work, they have mixed the operations inside one single question. What happened? How do we go about it? That is what we are about to tackle, the problems with mixture of operations. Now look at this particular fundamental question. Jerry, fundamental question. 2x plus 1 equal to 7. There is a plus in the work and there is a times in, because between the 2 and the x is a times. But after 2 times x, the whole thing here plus 1 will give you 7. Now, the idea is like this. Treat this or cover this particular place maybe with a hand and consider it as if maybe a hand covered plus 1 equal to 7, and find the hand first. So the hand equal to, because we have learned that whenever two things add to give you an answer, one of them is the answer minus the other added. So we're going to do 7 minus 1. So the hand is equal to 6. Meanwhile, the hand is removing your hand there, it is 2s that is there. So now we will remove the hand and we see that 2s equal to 6. They'll say, okay, if in this one, another operation is inside the work now. Now that we said, okay, if a number times 2 will give you 6, if two numbers multiply to give me an answer, one of the numbers is equal to the answer divided by the other multiplier. So I use the hand to help me finish plus from the work. Then now that plus is done, times was revealed after removing the hand. Then the number that we are looking for is actually 3. Interesting. But you know that we don't actually solve the work like drawing a hand. We don't actually solve this way, drawing a hand and all that. Okay. When they want to really solve this work in an examination situation, they will be keeping this whole thing repeatedly at all the junction where the hand was drawn, the 2s will be written like that. So the work will actually be solved like this. If the question is 2s plus 1 equals 7, keeping the 2x covered must be equal to 7 minus 1. That same 2s again is equal to 6. All those while it was being covered. Then at this juncture, we remove the hand from the cover and say, okay, it is even 2x. So if two numbers time to give an answer, one of the numbers is the answer divided by the other multiplier. And with that idea established, the number that is supposed to be found here is a 3. Now, is there any complete rule we can get? Yes, there is. There is a very complete rule to be handling the solving of such problem once and for all. What is the rule? Now, the first rule is group like terms. In our lecture 3, we talk about like terms and how to group it and the rule governing grouping them. After you group like terms, then you get the situation of a number is engaged somewhere. If a number is engaged in one side of the equal to adding, If you send it, you disengage it from that side of the equal to sign and send it to the other side. Once it was adding here, it will go and deduct from the other side. Undo numbers that are adding and subtraction first before you come and undo numbers that are multiplying or dividing. We don't undo numbers that are multiplying or dividing first. No. So in this very simple question, I will not say I'm trying to send the two away. No. You numbers that are being added or subtracted, they will go away first. You can do them even at once if you know you become so used to the rule. Let's bring another problem around and see for ourselves. Let's say we have m over 5 minus 7 equals to 13. So they are telling me that a certain number, if you divide it by 5 and you take away 7, you will get 13. It's okay. First rule, you may treat this as a group of like terms, because the 13 and the 7 are alike. Because they are numbers that don't have anything attached to them. They are alike. Or if you don't view it that way, you could say, use the rule I am just establishing now, that a number engaged somewhere subtracting, once you send it to the other side to go and add. And we've talked about this in lecture 2 when we're dealing with two special cases. So now we see that m minus 5, not yet treated, is recovered with the hand, equals to 13 plus 7. It was disengaged here when it was minus, it is now plus 7 because it crossed this sign, equal to sign. Now that we are here, we say that m minus 5 equals to 20. From here, everything that have to do with plus or minusing has been done. You now look at the operation that is left in the work. Division. Divided by is now left in the work. If you have viewed our lecture 1 on the basic algebra, you know. If a number divided by another is equal to an answer, then the top number is the answer times the dividing number. If you haven't watched that video yet, you go back and then you watch the video before you come back here, and you understand clearly that we are supposed to say that the number m is actually 20 times 5. And the number is actually 100. So the number that we are looking for that was hidden by m is actually 100. Divide 100 by 5, you will get 20. And that 20 take away 7 is actually 13. So if you are asking me to find the number that if you divide it by 5 and you take away 7, you will get 13. That number has been found to be 100. So whenever a problem comes, when all the operations are mixed in the work, you should not be scared. Target numbers that are alike first. Terms that are alike first. If a number is engaged adding, disengage it to the other side and subtracting. If it were engaged subtracting, disengage it and engage it elsewhere across the equal to sign. It will now be adding there. Do that to plus or minus first. After that, you come and look at times and division. If a number is engaged dividing, by the time it gets to the other side, it will go and multiply. And if the number was multiplying while here, if you cross the equal to sign, it will go and divide. Now let me give a particular question that involves maybe all 4 operations, plus, minus, times, and division, for example. Let's say I give you 2k over 5 minus 17 plus 8 equal to 21. So if you look at this, The 2 is multiplying the k, that's multiplication, is in the work. The 5 is dividing all of them, division is in the work. The 17 is subtracting itself from the subtraction is in the work, and plus is also 8. All the 4 operations, plus, minus, times, and division, they are all in the work. You must disengage numbers that are plussing and minusing first. So when I look at the situation, I say, okay, let me undo them step by step. Keep the 21 there because it is a host. Don't touch the sign. Those that are coming there, they will change their sign. This minus 17 plus 17 plus 8 minus 8. So you are doing minus here, you go and do plus at the other side. You are doing plus, you go and do minus. So by the time you look at your theta here, you know this minus this is actually going to give you something like a 9 added to this, and you'll be like 30. So 2k all over 5 equals 30 by total of everything here. Now that we are here, it is time to disengage the 2 and the 5. The 2 is engaged here multiplying. If you get to the other side, it will go and do the opposite of multiplication, which is division. The 5 is engaged at this side dividing. If you get to where the 30 is, it will go and multiply. If you know this rule of it, you can just do all of them at once and say k equal to 30 is a whole, so it should be there, times 5, c divided by 5, 10 to times 5, over 2, times 2, 2k, 10 to divide by 2. You can do them at once. So, if you do that and you can do your cancellation, 15 times 5, 75, right? And you have solved them. So the rule of thumb is that disengage numbers adding or subtracting first to the other side of the equal to. If a number was engaged subtracting at one side of the equal to sign, if you get to the other side, it will go and add. And if it were first of all being added like the plus 8, it turned to minus 8. Why are you getting here? By the time 21 plus 17 minus 8, total 30. Once the influence of plus and minus have been undone, have been completed in the work, it's time to look at which operations, which numbers are engaged using the other operations, times and division. Now I see 2 multiplying k, that's multiplication operation, and 5 dividing the whole 2k, that is division 2. A number engaged one side dividing. When it gets to the other side, it will do the opposite of dividing, which is multiplication. In our lecture 2, we said opposite of the multiplication is division, and opposite of division multiplication. Opposite of plus is minus, opposite of minus is plus. So the divided by 5 tend to times 5, and times 2 tend to divide by 2. Once you do that, if you can do them one after the other, but it really doesn't really matter. You can say this one, go and multiply this first, then later you write another line and you say you divide by 2. It will still end the same way anyway. But those who are familiar with the rule know that this one go and multiply and this one go and divide. And by the time you cancel, you will just finish the work off at this stage. So you will see that you are gradually developing ability to be going step, solving mass. Let's give another scenario and then we will be much more convinced what we are doing. Let's say I have 28 over 3k minus 16 equals or plus 16 minus, then put it here. So we look at a situation like this. A problem has come up, and we need to unravel the mystery of the number k. So what do? All numbers that are not carrying any variable are alike to their neighbors. So you send them to one side. If a number is engaged one side subtracting, by the time you get and cross this very side, it will go and plus. And this number being a positive, because if I check to the left of that, there's no sign there. So it is a positive 52. So if it crosses to this side, it will turn to negative 52. So in the first stage, I make 28 over 3k equals 3 over 4 plus 16 minus 52. At this level, because there are fractions in the work, you must use the fraction operator to actually deal with the work here. Treat this as over 1 and find the LCM of them. LCM of the least common multiple of these fractions is actually a 4. And if 4 divide 4, it is 1. 1 times 3 is 3. Plus, if 1 divide the 4, it is 4. 4 times 16 is what? 64. 1 divide 4 is 4. 4 times 52 is 208. So at that point, we can finish off by getting the total of this thing, this plus this 67, and if you take away that from there, you will be getting 141 divided by 4 over 4. That is 28 over 3k is equal to that. Now it's time to try to come out with the k number. From here going, you can use a number of operations, but then you should know that a number engaged dividing will go there actually multiplying, and a number multiplying will go there dividing. Or if you understand the rule that when a number divided by another equal to an answer, the dividend is equal to the answer times the divisor, you can actually use that rule to hear that it is this must actually times this to give the top number, because we have already established that in our lecture 1. So I should know that 28 equals 141 over 4 times 3k, like this. Then you can now get the total of these and then use to divide. So we get 28 equals 3 times these numbers, 313, 34, 12, and 313 plus 1 is a 4, all over 4, and that will be k. So I now disengage these two numbers to this side. The 20 this number 4 is dividing here, so it will become 28 times 4, and 423 is multiplying the k, so it will come and divide 423 will divide here, and we will make our answer like this. So at the end of the day, when you multiply, you are going to make 4 8 32. 428 plus 3 is 11. All over 423 equals to k. Or you can bring the k here and say that it's just the same. Or our k equal to 112 all over 423. See, you can leave the answer like that, or you can get it in decimal 0 point something. It will be the same. So look at the procedure. We got a 0.264, which is a 0.264, and that is the procedure to come out. So no matter how complicated the situation is, yours is to go by the rule steadily. A number engage subtracting. When it cross the equal to sign, it will go and add. And a number already adding, or if the number is having positive to the right of it, if you get to the other side of the equal to, it will go and subtract. Once you gather them there like that, you send a 16 there become plus 16, 52 over there become minus 52. Because of the fraction involvement, we want to total this part using fraction operations. And we know if you're adding or subtracting fractions, you are actually going to find LCM. So for 1, 1, the LCM of it will be a 4. And when we do the 4 divide 4, 1 times 3 is 3. 1 also divide 4 is 4. 4 times 6 is 64. 1 divide 4 is 4 times 52, 208. And the total of all that is 141 over 4. Then after that, use the idea from lecture 1. A number divided by another, if it's equal to an answer, then you should know that the dividend is always equal to the answer times the divisor. We've said that in lecture 2. If you can check it out by saying maybe 12 divided by 3, we know the answer is 4. And it's always, the 12 is 4 times 3 times 4. 3 times 4 will give you the 12. So whenever we have a situation of something divided another equal to an answer, we know that the bottom here 2 times the answer here. So once we get that done, we will be getting this, multiply this, and 3, 1, 3, 3, 4, 12. So I write 2 and carry 1, 3, 1, 3 plus 1 will be 4. 423 over 4 is a k. And from here, I try to move these numbers away from the k. And the 4 is dividing here. So when it comes here, to come and multiply. And 423 is multiplying here. So when it comes here, to come and divide. So 28 times 4 all over 423. 112 over 423 is your k. So the k is 112 over 423, which is equal to 0.264. So our lecture 4 is the one that summarizes the operations we've been doing from lecture 1 up to now. We have been able to establish a clean way to solve any linear equation in one variable, or equation involving only one letter or one thing that is unknown. By now, when we proceed in the lectures, we will come to where we don't know 2 things in the question and we can even find them out, all because we have laid the foundation where we know how to solve the situation where only one variable is in the work that we don't know its value. So I know at this level, you have come a long way to establishing yourself so that you can pursue the course without fear, without having to worry about you are not going to be able to make be a good mathematician or you pass an examination. No. It is little drops of water that makes the mighty ocean. Don't forget to subscribe, like, and share the video with others that will need your help. Then we will proceed. Later, we will put complete lectures on these on our website, ktkclasses.com. ktkclasses.com. That will be where we will eventually have the full course of our mathematics for the senior high school level. And I hope you've had a nice time up to now. The lecture is not finished. We will continue to the next lecture, lecture 5 on the basic algebra. See you then.